welcome to section. Today we will solve this particular question of physics. So here a system is given where an inclined plane making an angle of 37 degree with horizontal plane is given, and a mass of m, 2m and 3m attached in same string are placed in an over a pulley, right, over a massless pulley. This one is a massless pulley, and the inclined plane not at all frictionless. Okay, it has a frictional coefficient mu equals to half. The question is, if the system is released from the rest, what will be the acceleration in the mass 3m, right? Sin 37 and cos 37 values are given. That's all. Now, if you need to solve this type of problem, at first what you have to do is you have to consider every kinds of force working in this system. So for instance, if we assume the acceleration will be a, if we assume the direction of movement will be toward this direction. Okay, you can take the opposite direction also, but I am taking this direction. Okay, now the mass, for the mass of 3m, the weight is working in the direction downward, which is equals to 3mg, and for the mass of m, the weight will be in this direction mg, and also similarly for mass 2m, the weight is 2mg. Now m and 2m is in inclined plane, which is making an angle of 37 degree. So if we divide this weight into two perpendicular component, we get a component which is perpendicular to the inclined plane, and also we get another component which is parallel to the inclined plane, right? Similarly, if we divide it into two components, we will get this and this. From a simple geometry, we get that this, if this angle is theta, if the angle of inclination is theta, then this angle will also be theta, right? So this will be theta also. Here theta equals to 37 degree. So this component will be mg cos theta. Okay, and this component will be mg sin theta. Similarly here 2mg cos theta and 2mg sin theta, right? Clear? Now this weight is in this downward direction, right? So in this side of pulley, there is a mass attached m and 2m. So there will be a tension force which will be pulling the 3m in this direction. So the tension force will be in this direction T1. The tension force is T1. We are assuming this tension force T1, right? So the direction of the T1 will be this side, which is pulled by m and 2m together, right? And we know, as this is a massless pulley, the tension in the both side of the pulley will be same, as it is a massless pulley. So similarly, the 3M mass will be pulling this portion of the string. So there will be a tension force which will be T1, same. Okay, similarly, in this part of the string there will be a tension force also. This M will be pulling this 2M in this side. I am taking this tension force as T2, right? And this 2M will pull the M in this side, so it will be T2 also, right? And at last, as the system will be moving and the inclined plane is not frictionless, so there will be a friction. When there is a movement, when there is a motion in a frictionless plane, there will be a frictional force which will oppose the movement, right? And it will this force direction will be opposite to the direction of motion, right? So the frictional force will be working in this side. This frictional force will be working in this side, opposite to the motion. So I am taking the frictional force for mass M is F1, and frictional force for mass the mass 2M is F2. Now we know that frictional force Fr equals to mu into R. We know that frictional force Fr equals to mu into R. R is reaction force, right? So here, what is the reaction force? As this is an inclined plane, mg cos theta is working downward and perpendicular to the inclined plane. So the inclined plane will be the inclined plane will experience a force or weight of the particle or body mg cos theta. The inclined plane will experience the weight of the body M will be mg cos theta, because this is directly perpendicularly the perpendicular portion of the weight mg is mg cos theta, not the mg whole mg will be experienced by the inclined plane, but the mg cos theta, which is perpendicular to the inclined plane, will be experienced as a weight. And if there is a weight of mg cos theta on the inclined plane, the inclined plane also will have a reaction force. Also, we have a reaction force of mg cos theta in the opposite side, right? And for similarly, as the perpendicular portion of the 2mg weight is as the perpendicular portion of the inclined plane for 2m mass will be 2mg cos theta. For 2m mass, the perpendicular portion of the weight 2mg is 2mg cos theta. So there will be a reaction force toward this side, right? So reaction forces are R1 equals to, mg cos theta. Similarly, R2 reaction force for 2m mass will be 2mg cos theta, right? Clear? So the frictional force F1 will be mu into mg cos theta, and also F2 will be mu into 2mg cos theta, right? Now I already told you the direction of the frictional force, right? Now what we have to do is, the last step is, we have to consider the free body diagram of the mass, free body diagram of the mass separately, right? You can skip the this portion in the exam because you will have a limited time, but as I am explaining this question, I will draw the free body diagram, right? This is nothing but a separate diagram that how the forces are working on it. So there is 3m mass, right? For 3m mass, force 3mg, a weight 3mg is working downward, and tension force is T1. We can see from this diagram, okay? So, and one thing is, as the whole system has a acceleration, we assumed a, so the acceleration a, the force associated for the acceleration a in the mass 3m will be 3 into m mass into a, which is P equals to mf. Force equals to mass into acceleration, 3m into a, right? So we can draw a equation, we can write a equation here, that 3mg minus T1 equals to 3ma, right? The net force 3mg minus T1 will be equals to the force in which the force which is the cause of acceleration in the mass 3m. Okay, and now I will draw the mass m here, this mass, right? For this mass, we can see that this mass, the tension force in this direction T1, and the in downward direction, in this direction, the force workings are frictional force F1, and also the T2. Here you see the m is pulled by 2m, T2, right? And also the horizontal portion of the weight mg, the parallel portion, actually not horizontal, this is parallel portion of inclined plane, mg sin theta portion, right? So mg sin theta is also included in this side. So what will be the equation for it? We can write a equation. T1, you see T1 here, T1 minus T2 minus mg sin theta minus F1. We know the value of F1 equals to m into a. So this is number 2 equation. And if we consider the mass 2m here, we consider the mass 2m here, we will see there will be a tension, T2, which is pulled by mass m this side, right? Not mass m, but also m and 3m, the whole system will be pulling this 2m, right? So this will be T2, and here the force 2 mg sin theta in this direction, which is parallel portion of the inclined plane, inclined plane, and this is the parallel portion of the what this is the component of the 2 mg, which is in this direction, which is parallel to the inclined plane, 2 mg sin theta, right? And also the frictional force F2, we calculated it, F2 value, right? So we can write the equation as T2 minus mg sin theta, 2 mg sin theta, sorry, 2 mg sin theta minus F2 equals to 2 ma, right? The acceleration will be a, so the force associated to the acceleration in 2m mass will be 2ma, right? So we got 3 equation, right? Now if we add these 3 equation, we see T1 will be cancelled out, T2 will be cancelled out, this, and there will be 3 mg, this 3 mg, we are adding 3 equation, right? So 3 mg plus 3 mg minus mg sin theta, 2 mg sin theta, that means 3 mg sin theta, right? 3 mg sin theta, right? And so 3 mg minus 3 mg sin theta, and we see minus f1 minus f2 equals to, we see 3 ma, 5 ma and 2 mm, that means 6 ma. Now we need to calculate what? A, right? We need to calculate A. Now sin theta equals to what? Sin theta equals to 0.6. So 3 mg minus 0.6 means 1.8 mg, and f1 will be what? Mg cos theta, cos theta means 0.8, and a mu equals to 1.2, that means f1 equals to 0.4 mg, and mu 2 mg, that means half and 2 will be cancelled out, and mg cos theta equals to 0.8, that means 0.8 mg equals to 6 ma. I am moving it, okay. Now we see the equation 3 mg minus 1.8 mg minus 0.4 mg minus 0.8 mg, that means 3 mg minus 1.8 and 0.4 minus 0.8, that means 3, this is how much? 3 mg. So 3 mg will be cancelled out, that means 6 ma equals to 0, that means a will be 0, that means no acceleration, will be produced if the system is released from the rest. No acceleration will be produced. Okay, if you have any doubt related to this solution, then you can put a comment below, and subscribe my channel to get more problems and solution like this. Okay, bye for now, thank you.